Alright, so 2-4 uses deductive reasoning. They are asking you here to write the converse. So who would like to bless you? Who would like to tell me the converse of if I am thirsty, then I drink water? If I drink water, then I drink. Yep, if I drink water, then I am thirsty. If the car outside is wet, then it rained. Who wants to do the converse of that?
If it rains, the car can be wet.
Okay. Alright, so the converse just flip-flops the if and then statement. So we use the converse a lot. Your new definition today would be deduce. To deduce is to use known facts to reach a conclusion. So we're not using inductive reasoning uses educated guesses, uses your experience. That's what detectives use when they're trying to solve a crime. Whereas deductive reasoning uses known facts. If this, then that. If this, then that. If this, then that. It's nothing that we're making an educated guess at. We have to have a statement of truth in order to create another statement of truth. And there are two different laws that we use to do that. I don't care about the use your vocabulary part. The first property is your law of detachment. I don't necessarily like how they described it here. Here's what you're going to write that the law of detachment is. The law of detachment looks like this. If P, then Q. So they're going to give you a full conditional. If this, then that. Then they're going to give you, then they're just going to give you P. So the first statement they're going to give you is a full conditional. The second statement they're going to give you is just a partial conditional. Thus the word detachment. Think of your arm being just hanging here, being detached. Okay? You're kind of left hanging here in the second statement. If P, then what? Notice that these are both P. This P mirrors this P, but it's more specific. So, for instance, it might be something like this. If an animal, and I can spell animal, is a dog, then it pants a lot. Whether you agree with it or not. Let's just assume that's completely true. If an animal is a dog, then it pants a lot. So that's statement number one. Statement number two, Jojo is a dog. Could you convert Jojo as a dog to an if-then statement? If something is called Jojo, then it's a dog. Does that sound reasonable? No. So this is a partial statement. Doesn't this statement right here mirror if an animal is a dog? But it's really specific. It's calling that dog Jojo. So it's saying the same thing, but it's just being really specific and direct. What would your conclusion then be? There you go. Jojo pants a lot. So the conclusion mirrors the original conclusion, but again, it's specific. It names Jojo in it again. So your third statement up here for your law of detachment, statement 3, is going to be Q. Now they're not going to list the statements out 1, 2, and 3. They're going to list it in, paragraph style format. Just put them all together. Do be aware that this is the one right here that you are coming up with. This is the one that you come up with. They're going to give you the first two. You come up with the third. So let's look at this one right here. I would even get used to naming it. So they give you this question, you're writing out all of this. And if I were writing it out, I'd just write it out as statement 1, 2, and so forth. You need to identify whether it's law of detachment or the next one that we're going to talk about, law of syllogism. So if there is lightning, then it is not safe to be out in the open. Is that a full conditional? Yes, it's got the if-then. And it may not have if-then, but if you can put it in the if-then form, then it counts as a true conditional. The second statement, Marla sees lightning from the soccer field. Is that a full conditional or a partial? Full or partial? It's partial. So Marla sees lightning from the soccer field. Doesn't that mirror if there was lightning, but it's really specific about where she saw the lightning and who saw the lightning? So it is if it doesn't mirror that, if it says instead, if statement number 2 says instead, Marla feels it is not safe to be on the soccer field, if it said that for statement 2, that's mirroring the conclusion, not the hypothesis. So be really careful. They're going to try to trick you by mirroring the conclusion. It has to mirror the hypothesis, but be specific. So then what would our conclusion be? So if Marla says lightning from the soccer field, wouldn't our conclusion be to mirror the conclusion but be specific? So Marla, well, let's just go ahead and write it over here. So statement 3, you write what you think it would be. I don't necessarily like the way it. So you write it properly. Marla sees lightning from the soccer field. What do you conclude? What do you conclude?
Did you say that Marla actually used the...
What does the original conclusion say up here? Then it is not safe to be out in the open.
Because I reduced it out, so you said Marla is not feeling safe.
And you don't necessarily have to say Marla in the second one because we already said it first. You could say she,
Okay.
or then Marla feels it is not safe to be on the soccer field, or then she doesn't feel. So you can use that pronoun after you've used the noun. So statement 3. Then it is not safe to be on the soccer field. You don't have to use the word then in there, but you can. It makes it easier sometimes. So how is the law of syllogism different than the law of detachment? So here's your law of syllogism. Again, I don't necessarily like how they showed it. I like to show it in this form. So you've got statement 1 is going to be a full conditional. If P, then Q. So they're going to give you one whole full conditional. The second statement is going to be another full conditional. So there's your huge difference between law of detachment and law of syllogism. In law of syllogism, you get 2 full conditionals. So, and Q, then R. So notice that we end with Q here, we start with Q here. So remember I showed you at the very beginning of this unit, if you give a mouse a cookie, then you'll want a glass of milk. What was the next statement after that? If he drinks a glass of milk, doesn't that mirror what we just ended up with? So that book is using throughout it law of syllogism, all the way through. And so your conclusion, and this is the part that you come up with, your conclusion is going to be, if these two overlap, so if you give the mouse a cookie, then he's going to want a glass of milk. If you give him a glass of milk, then he gets a milk mustache. Isn't your conclusion that if you give a mouse a cookie, he'll get a milk mustache? Couldn't you jump to that conclusion and just leave the cookie part out of it? Sure, yeah, you actually can. You can. Assuming that all those statements are true. So then you're going to just put these two together, because those are the two that are not overlapping. The if statement that you start with and the conclusion that you end with on the second statement, you're going to put those together. So you're going to put them together as then P, then then are. So this is a statement that you are coming up with. So they've got here statement number 1. If it is July, then you are on summer vacation, full conditional. If P, then Q. Then they go on to the second statement of another full conditional. If you are on summer vacation, doesn't that mirror then you are on summer vacation? So these two are the same. We can just take them out of the two sentences and put the rest of the sentences together. Then you work in a smoothie shop. So your third conclusion statement is, if it is July, then you work in a smoothie shop. Number 10. If a figure is a rhombus, then it has 4 sides. If a figure has 4 sides, then it is a quadrilateral. Statement number 1, statement number 2. You are coming up with statement number 3. They've started it for you. It has 4 sides. So you should be putting the other two together. So if a figure is a rhombus, then it is a quadrilateral. So big difference. And by the way, those of you who know your mathematical properties, this follows the transitive property. So this right here follows the transitive property. We will use the transitive property a lot in proofs. If this, then that. If this, then that. Then we'll take the two of the conclusions and pull them in together. I don't care about problem number 2. Let's look at problem number 3. What can you conclude from the following information? What is your reasoning? So don't worry about question 15. We're just going to go through this little by little and just writing what we need to write in. If a river is more than 4,000 miles long, then it is longer than the Amazon. So that's statement number 1. Is that a full conditional or partial? It's a full conditional. Then statement 2, if a river is longer than the Amazon, then it is the longest river in the world. So that's statement 2. Full conditional or partial? Full conditional. It's trying to, now they're going to put in statements here that may or may not follow the law of syllogism or the law of attachment. So just because they did it to you doesn't mean it's true. So that's a full conditional. Does that follow law of attachment? You're being left hanging. Or does it follow law of syllogism? Syllogism, you've got 2 full conditionals. So shouldn't your conclusion be what? Full conditional or a partial? Full conditional. Law of attachment is where you have a partial. They give you the if, you come up with the then. So here's the conclusion. Well, here's the third statement. The Nile is 4,132 miles long. Well, here's a couple of things. They have combined the law of syllogism and the law of attachment together in one problem. Because haven't they given you a third statement? You haven't had to come up with that yourself. We can use these 2 statements right here. This is your law of syllogism. So we can use those 2 statements right there. Look to see what was repeated. It is longer than the Amazon. A river is longer than the Amazon. Isn't that the part that's repeated? So what is the statement that we're going to get from that? So what's statement 4 that we can get from that? In the first 2 statements, if a river is more than 4,000 miles long, then it's longer than the Amazon. If a river is longer than the Amazon, then it is the longest river in the world. So what's our statement that we're using to conclude here? Eric? Hmm? You're going to tell me what this fourth statement is. Not yet. So I want to use these two statements only. We're not looking at that one yet. We don't know about the Nile. So using those two statements only. So if a river is more than 4,000 miles long, then it is the longest river in the world. So that's our fourth statement. Now, if you combine statement number 4, and let's just rename this one statement number 5. And here's why. Can't I use this one and this statement together to make another conclusion? If a river is more than 4,000 miles long, then it is the longest river in the world. The Nile is 4,132 miles long. Does that mirror the if statement here? Yes or no? The Nile is 4,132 miles long. If a river is more than 4,000 miles long, does that mirror it, but is more specific? Yeah. Isn't this a full conditional? Isn't this a partial? So the second part is using law of detachment. So now using law of detachment, what is statement 6? Dominic? Then the Nile is the longest. River in the world. Since they already gave us that part of it, we only want to write the then part. So sometimes they're going to put both law of detachment and the law of syllogism together. We tend to like to use the law of syllogism first and then do the law of detachment. So the next part that I'm going to give you, before I give you that, let's look at these. Let's go ahead and look at the lesson check. Is it possible to draw a conclusion from these two statements here? If a figure is a three-sided polygon, then it is a triangle. Figure ABC is a three-sided polygon. So if you can make a conclusion, go ahead and make it. But I want you to identify, is it the law of detachment or is it the law of syllogism? And it can be trying to be the law of detachment or trying to be the law of syllogism, but if it doesn't follow it correctly, then it actually isn't that law. But they will often try to make it look like they're functional. So you write your conclusion, if possible. And then chat amongst yourselves. Talk about if it's the law of detachment or the law of syllogism and what your conclusion is if you found it. So chat. Danny, why are we asleep on our desk? Can you check what you come up with? What law is it? Did you get a conclusion? Okay, what did you get for a conclusion?
I got figure ABC is a three-sided polygon.
When you say that it's a triangle, you have to be specific. So because otherwise you're saying exactly what the original conclusion was. So you have to take that specificity. That wasn't even right. You have to, I can't speak, it's not even 10 a.m. So you have to take that specificness of figure ABC, and that has to be part of your conclusion. So how are you going to fix that? Then it's a triangle.
Figure ABC.
There you go. And remember that your conclusion is the only part I'm looking for. You're not going to repeat that in statement. So, Kate, was this a use of law of detachment or use of law of syllogism? Detachment. Why? They gave you one full conditional and one partial. Detachment. Partial, right? So this is law of detachment. And then because of that specificness, our statement, so this is statement 1, this is statement 2, our third statement, statement 3 is going to read figure ABC is a triangle. Alright, so now let's look at the back. We don't care about 19 and 20. So let's look at this particular statement that a student came up with, and it is wrong. Birds that weigh more than 50 pounds cannot fly. A kiwi cannot fly. Now, a kiwi is not a fruit in this instance. I will admit that I was like, a kiwi cannot fly? A kiwi's a bird. Again, it was not before 10 a.m., or it was before 10 a.m. when I was looking at this. I'm like, a kiwi. So there's a bird called a kiwi, just to let you know. A kiwi cannot fly. So a kiwi weighs more than 50 pounds. What is wrong with this? Do you know what a kiwi bird is?
Yeah.
That's impressive.
That's
Kiwis
like
don't
little
have
weak
wings.
stumps.
So it's not because they're more than 50 pounds?
No, they're just, I don't know, they're there. They just don't have wings.
That's awesome. So the first statement is, so we're going to write the birds that weigh more than 50 pounds cannot fly. We're going to write that as a if-then conditional. So if, what? What's the subject of the sentence? Birds. But that weigh more than 50 pounds, doesn't that describe, cannot fly. That weigh more than 50 pounds, doesn't that describe the bird? I swear I turned that off. Nope, that was me. Doesn't it describe the subject of your sentence? So I can't cut the sentence here at birds. I have to cut it here because that's a phrase that describes that noun. So birds that weigh more than 50 pounds. If a bird weighs more than 50 pounds, then it cannot fly. Let's accept that as true. So that's statement number 1. Then their second statement was a kiwi cannot fly. So the second statement that this child wrote was a kiwi cannot fly. What is wrong with that statement? What is this trying to follow, by the way? Law of attachment or law of syllogism? Yeah, that's not a full conditional, right? So Dominic, what's wrong with this? What? It mirrors the conclusion, right? Isn't it supposed to mirror this right here? If a bird weighs more than 50 pounds, does this talk about the bird weighing 50 pounds? No. So there's the problem. What should have happened was a kiwi weighs more than 50 pounds. Shouldn't that have been what was said? So instead of this, the student should have said a kiwi weighs more than 50 pounds. Then what would your conclusion have been? Instead of this right here, what was your conclusion again? Look at the conclusion here. You must mirror it, but be specific. No, because we have this already. A kiwi makes more than 50 times. We've already said that. So what are you going to say directly after that? A kiwi cannot fly. So a kiwi cannot fly. So don't try to put the two conditionals together again. Does that make sense? You're writing the conclusion as a statement, separate statement. All right, so the next part I don't want you to try to copy down because you'll never have enough time to copy it down. You'll go crazy trying to do so. So instead, I will copy them for you and give them to you on Monday, but if you want them prior to that, because maybe you want to use it to do homework in, that's fine. They'll be online and you can print them off of my website. Just a moment. Close these off. Alright, so I'm going to put some statements up here, and it's your job to determine if it's law detachment, law syllogism, and then what if it is properly used, what conclusion could you come up with? Oh. All right, so here's the first. Don't write this down. You'll never have time. So I just want you to look and think. If a student gets an A on a final exam, then the student will pass the course. Full, conditional, or partial? Full. Felicia got an A on her history exam. Full, conditional, or partial? Partial. So this is law of detachment, right? Does Felicia got an A on her history exam mirror the hypothesis? A student gets an A on a final exam. Does that mirror that?
Yes.
And it's specific, right? So what would your conclusion be? If you look like you're falling asleep, I'm calling on you. So you might want to look really awake. Sam? He didn't look asleep, but I'm going to call him. We already said that, right? So what's your conclusion? So you're going to mirror the conclusion up there, but be specific. So the conclusion up there is the student will pass the course. So what are you going to say? So Felicia will pass her history course. That's your conclusion. Does that make sense?
Yeah.
Okay. All right, so the next one. And I just put, then Felicia will pass the course, or you could say history course. Either way is fine. So the next one. The next one involves geometry. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. Full, conditional, or partial? Full, conditional. Is that true, by the way? If a ray divides an angle into two congruent angles, then the ray is an angle bisector? Yep, definition of angle bisector. Then the next statement says, ray RS divides angle ARB so that angle ARS is congruent to angle SRB. There's a lot of specificity. Why can't I say that today? I know, I can't say it today. What is up with that? There's a lot of specifics in there, isn't there? So look at the hypothesis of the first statement. If a ray divides an angle into two congruent angles, does this go any further than saying that? So my point is it a full, conditional, or a partial? Ray RS divides the angle so that there are two congruent angles. I took out the specifics. This is just the if statement, isn't it? Isn't it exactly mirroring the if statement? Always go back and reread the if statement and look to see about the new statement. I know it's a long if statement, but you really can't say if ray RS divides the angle, then you get congruent angles. You can't write an if-then statement for that. That would be wrong, by the way. So that's actually mirroring just the if statement. So it's a partial. So what law are they using? Law of detachment. So then you want to, for your third statement, you want to rephrase the ray is an angle bisector, but be specific. So think about it. The ray is an angle bisector, but you're going to be specific. You're going to write it as a sentence. Mariah, what do you think?
Yeah.
I can't hear over the lower what? Yeah, what is your conclusion? Be specific. So rewrite it exactly as original conclusion, then the ray is an angle bisector, but be specific. So then, what ray?
Ray RS.
Is an angle bisector. That's all I would say. Then ray RS is angle bisecting. You don't have to mention what angle it's bisecting, but you have to be specific about what ray. So law of detachment uses that. So then I did put the angle in there, but you don't have to. All right, so then the third question. If a figure is a square, then the figure is a rectangle. Full, conditional, or partial? Full. True or false? True. Squares are rectangles. If a figure is a rectangle, then the figure has four sides. Full, conditional, or partial? Full. So what law is it following? Syllogism. What are you looking for it to be the proper law syllogism? The conclusion of your first statement is the hypothesis of your second statement. So the conclusion here, then the figure is a rectangle, should be repeated here as the hypothesis, is it? If a figure is a rectangle, right? Isn't that correct? So then can't I take out, then the figure is a rectangle, if a figure is a rectangle, can't I take those two parts out and put what together? If a figure is a square, then the figure has four sides. Is that true? Yeah. What's nice about the law of syllogism is there's no editing needed. You just take out the repeated parts and put the other two phrases together. So we end up with, if a figure is a square, then the figure has four sides. So law of syllogism you should like because there's less thought processes to it. So statement number 4, if you do gymnastics, then you are flexible. Full, conditional, or partial? Full, conditional. Next statement, if you do ballet, then you are flexible. Full, conditional, or partial? Full, conditional. What law are they trying to use? Syllogism, because you've got two full conditionals. Let's see if it's a proper use of syllogism. What you conclude here, then you are flexible, is what you should start with here. Then you are flexible. Is that what they started with? No. So don't try to say if you do gymnastics, then you do ballet. They haven't even used the law of syllogism correctly here. How could we change statement 2 for them to have used law of syllogism correctly? Right?
If you are flexible, then you do ballet.
Correct. So if they had used the converse of this statement here, then we could have said if you do gymnastics, then you do ballet. That would be okay. But because they did not use the law of syllogism correctly, no conclusion is possible. So there are several questions in your homework tonight where you can't make a conclusion. So your job is to, number 1, determine if they're trying to use law of detachment or law of syllogism, and have they used it correctly. And then if they have, then you can draw a conclusion. So let's look at the next one. And again, these will be online. So if you want to print them out and restudy them, you can. And then I'll give you a copy on Monday. I just didn't have time this morning. So number 5, if two angles are adjacent, then they share a common vertex, full conditional or partial. Full conditional. Angle 1 and angle 2 share a common vertex. Full conditional or partial? That is a partial. So what are they trying to use? Law of detachment, right? Is this the proper use of law of detachment? I see specifics here. It's like aluminum. How many of you can't say aluminum? See, I can say aluminum. They do use specifics here, right? Is it the proper use of specifics for the law of detachment? What are they supposed to be mirroring? If two angles are adjacent, right? So if they had said angle 1 and angle 2 are adjacent, then what would you have concluded? Angle 1 and angle 2 are adjacent. What would you have concluded? Mirror their conclusion, but be specific. Angle 1 and angle 2 share a common vertex, right? So this is actually the conclusion you would have made if they had mirrored the hypothesis correctly. But since they didn't, no conclusion is possible. All right, statement number 6.
Why can't you say
Because, good question. So she wants to know, why can't you say angle 1 and angle 2 are adjacent? Just because they share a common vertex doesn't mean they're adjacent, right? Could they be vertical? So because they haven't used it correctly, now I'm creating a statement where I could write a counterexample to it. But if I had said angle 1 and angle 2 are adjacent, they have to share a common vertex. So there's no way I could write a counterexample to that. Although normally that's not something I would say about adjacent angles. Normally when I hear adjacent angles, I don't think common vertex. What should you be thinking? They share a common side. So now if that had been what they had said, they share a common side, angle 1 and 2 share a common side, well, your conclusion could be that they're adjacent, but it still isn't the proper use of law of detachment because they didn't mirror it correctly. Doesn't mean you don't have a correct statement, but we like to mirror stuff in our geometric proofs. All right, so another geometry question or statements. If ray AB and ray AD, that's a D, not a P, are opposite rays, immediately in your brain you should be thinking lots of things about opposite rays, then the two rays form a straight angle. Full, conditional, partial? Everybody? Full. True or false? It's true. If two rays are opposite rays, then the two rays form a straight angle. Full conditional or partial? Full conditional. So what are they trying to use here? Law of syllogism. Is it the proper use of law of syllogism? In the law of syllogism, what does the second statement have to do in relation to the first statement? Whatever the conclusion was, they have to restate that conclusion as the hypothesis for the next statement. So the conclusion here was that the two rays form a straight angle. Is that what their hypothesis was here? No. In fact, they, if we had written the converse, then we would have a proper law of syllogism statement, correct? So again, no conclusion is possible. This last question, tell me what you think about it. If you live in Accra, then you live in Ghana. Full conditional, partial? Full conditional. If you live in Ghana, then you live in Africa. Full conditional or partial? Full conditional. So we have two full conditionals, and then we have Aisa lives in Accra. Full conditional or partial? Partial. We have two full conditionals and a partial. They are trying to, when they do that to you, they are trying to combine the law of syllogism and the law of detachment together, which is fine. It wasn't that last one that we were dealing with or one of the last ones, with the river, right? And the Nile River and whatnot. So this is doing the same thing. So let's just work with the first two statements. If you live in Accra, then you live in Ghana. If you live in Ghana, then you live in Africa. That's a law of syllogism, right? Is it the correct use of the law of syllogism? Their conclusion, then you live in Ghana, is the hypothesis of the next statement. You live in Ghana, right? So can't I take away you live in Ghana and just put if you live in Accra, then you live in Africa together as one statement? So from those first two statements using law of syllogism, we can conclude if you live in Accra, then you live in Africa. Now I'm going to take that statement there and combine it with this one. Aisa lives in Accra. That's now combined with the statement we just came up with. Isn't that right there the law of detachment? Is it the proper use of the law of detachment? Does this mirror the hypothesis here but is more specific? Yes, because it's who lives in Africa. Aisa lives in Africa. So what's your conclusion? What's your conclusion? Who? Aisa lives in Africa. So your conclusion but you had to have written if you live in Accra, then you live in Africa first before you can conclude that Aisa lives in Africa. So you can't jump to a conclusion and miss something in between. And my point to you is this: you're like, well, why couldn't I just jump to that? Duh. When you write a geometric proof, you can't skip parts of that proof to jump to what you consider an obvious conclusion. You have to put everything in there using the law of syllogism, using the law of detachment. Otherwise, geometry is a geometric court of law. If you miss something in court and you don't lay down the right foundation, then you haven't proven your case fully. And so if you've ever, my dad's a lawyer, if you've ever seen the writings of a lawyer or listened to a lawyer speak, oftentimes they talk a lot and use a lot more words than they need to, right? So that's kind of what we're doing here. We're laying down a foundation and being very, very clear about it. Any questions?